Okay, so what we're going to be doing here is finding the exact values, all right, given a certain equation. So essentially, we do algebra until we get the arc sine by itself, and then we take a look at the situation. And then just a reminder, in order for things to be defined, right, our arc sine, the range is from negative pi over 2 to pi over 2, all right? And then for for the inverse cosine, the range is from 0 to pi. And for tangent, we have negative pi over 2 to pi over 2. Right? So we have to kind of keep those in mind when we're finding when we're solving an equation with the arc sine and the arc cosine and the arc tangent in it. So let's go to work. So here, essentially pretty easy to get the arc sine by itself. We just divide both sides by 4. And so this is basically saying that the inverse sine of x is 5 pi over 4. So we got to find a value, right, that when I put it into the inverse sine, gives me an output of 5 pi over 4. But when we look at this, right, the high end output is pi over 2. So 5 pi over 4 is sitting over there in quadrant number 3, right, and it's way out, right? This is the end of quad 1, and this is the end of quad 4 rotated positively. So this angle does not fall, right, within that range for sine, or for inverse sine. So therefore what this means is that there's no solution, all right, as far as the inverse sine is, okay? So we have to be very careful. Again, be cognizant of our domain value. So there's no solution to that equation because the arc sine is not defined, all right, or its range is only between negative pi over 2 to pi over 2. So we can't go any further. The next one, again, following some algebraic rules, I'll probably begin by adding 5 pi to both sides. All right, so that gives us 6 inverse cosine of x equals 5 pi. Divide both sides by 6, all right, and we basically have the cosine inverse of x is 5 pi over 6, which is well within that range, right? So this is basically sitting there in quad 2, right, which is, so we have, there's pi, and definitely 5 pi over 6, right, doesn't quite get over to pi, right, in terms of a half rotation. So this is defined. So our x is the cosine of pi over 6, and then busting out a unit circle, I think we find that the cosine of 5 pi over 6 in there, this is basically a 30-degree reference, so I believe that's negative square roots of 3 all over 2, all right, for that particular situation, right? So 30-degree reference, yeah, negative square root of 3, 1, and 2, yeah, so negative square roots of 3 over 2 is what the cosine of 5 pi over 6 is. So the next one, again, it looks like the arctangent isn't alone, but that's the argument, right? That's the input of the arctangent, and it's equal to pi over 3. So does pi over 3 fall within that range? Yes. All right. It's basically sitting in quad 1, and this is 90 degrees, and that's 60 degrees. So we're well within this range. So this is well defined. We actually do have a solution for this particular case. Let me move this up. Okay, and so essentially we're looking at x minus pi over 4 is equal to the tangent of pi over 3, right? And again, thinking of a 60-degree reference, right, we get the square root of 3 and 1 and 2. So tangent in this case, that's basically the square root of 3 is equal to x minus pi over 4, right? Let me make sure, yeah, so tangent is opposite over adjacent. All right, so we've got that. And so to solve for x, I'll add pi over 4 to both sides. And so our solution is the square root of 3 plus pi over 4. So there would be the solution for that particular guy right there as we apply the arctangent, consider its range, and then just keep solving using our algebra. All right, so be careful, again, be aware when we're solving equations. If the inverse function is equal to something that's out of its range, there's no solution. If it is equal to something that's within its range, then we can go move forward and we just follow our algebra, figure out where we're at again in terms of quadrants and whatever for signs, and just keep on following our algebra. All right, so there's our first stab at solving equations. What was nice about these particular equations, there was only one inverse function involved. The second round, we're going to be looking, there's going to be two, all right, and we'll talk about how to solve those in a video coming soon.